how exactly, step by step, a blockchain works.
Prepare for launch. 3, 2, 1.
Now, this does not apply to all blockchains, but generally, most blockchain works this way, and almost all works this way with a bit of variation here and there. Now, just now I did mention about if you would like to send any transactions from one party to the other party, you need to have an account or an address. So it's just like at the very left-hand side, the person icon over here with a series of numbers or characters that basically represents your address. So with this, and you have the private key that you're supposed to keep it to yourself only, you sign the transaction. It's just like in a check, you write there who you want to send to and what is the amount, and you put down your signature. Without your signature, the receiver can't cash this check. And at the bottom of the check have the information of your account. So that's how the concept works. After you sign the transactions, you announce it to the network. So the network will share your information to everybody in the network. So they know they're like, oh, okay, IV want to send 10 Bitcoins to V. Then they put all these transactions into their ledger called a candidate block. Why is it called a candidate block, not just a block like a block right away? It's because now everybody in the network only collecting transactions. And why they're willing to collect these transactions is because come with the transactions, there is transactions fee. It's just like, we need to pay the bank for a certain fee to do clearance for our check and such, especially for the international remittance. When they have recorded all the transactions in their candidate block, what they're going to do is they're going to compete with each other in order to find solutions to equations, which whoever finds the answer will be able to get their candidate blocks added to the chain. Now I repeat, when the person have signed a transaction saying he want to send a certain amount of coin over to the other person, says A, Alice, want to send 10 Bitcoin to Bob. Alice signed the transactions with a private key and announced these informations to the network. And the nodes that get this information is going to put the information on these transactions on the candidate block and also share this information with the peer. It means everybody else in the network. Then, at the same time, every one of these nodes is going to compete with each other and see who are the first person or the first nodes that be able to guess the answer to a puzzle, and that person or that node is going to be able to add the candidate blocks to the chain. Now, every node have its own candidate block, but only one node will be able to add the candidate blocks to the blockchain and get the rewards, which is the newly minted Bitcoin and the transactions fee from the transactions. And not every node will have exactly the same candidate blocks with exactly the same transactions. Why? Because there will be some latencies in the internet, right? Even though sharing of information on the internet is very fast, there are still times that at the other corner of the world will get the information a few minutes later than this corner of the world. And if between that difference of the time, the block created, the other person, the other nodes at the other end of the world won't be notified just yet. And probably just in the split of seconds, the other one also thought that it has guessed the right number. There could be two nodes in the network that thought their block is the one that being added to the chain. And this will cause the chain to fork. Blockchain always have only one precedent block and one subsequent block. There won't be two blocks before it or two blocks behind it. Even if there is two blocks behind one block, it will only be temporarily, because right away the block is formed, the network is going to start to find the answer to the next puzzle again, and then they will start to add their newly formed blocks to the chain again. Remember, just now I mentioned there could be two blocks behind one block, so they're going to choose which one they're going to add it to. After a while, two of this block, there will be one that with more blocks behind it and one with less. And the block with less blocks behind it is going to be dropped. And we are going to follow the longer chain, where we call the true chain, or sometimes they just call the longest chain. Alright, so that is the situation that could happen. But the algorithm will correct itself after some time. Now, so that is the reason if you have used cryptocurrency before, or you have traded cryptocurrency before, and usually when you transfer the cryptocurrency to an exchange, they need to wait until a certain period of time before they can credit your account with the cryptocurrency. It's because just in case your transactions falls at the shorter chain and it drops. When it drops, it means that your transactions it will be reversed. Now, this is not considered deleting the transactions or editing the transaction. It's simply that they will take it as if that transactions never happened. But there could be times as well that your transactions would be included in both the blocks that fork. Then even if that shorter chain being dropped, your transactions still in the longest chain. So anyway, there is always only one block before a block and one block after a block. In any time there is two blocks after a block, one of it will have to be dropped after a period of time. Usually, for example, for Bitcoin, after an hour, you can consider it very safe, because by the time you will be able to these two chains will be able to differentiate themselves, which one is shorter, which one is longer. So this is very common in exchange or in any shops or company that accept Bitcoin or other cryptocurrency. They will have a period of time to say that like the transaction is only agreeable after a certain period of time. All right, and that is also part of the consensus protocol that I mentioned earlier on. The consensus protocol have two functions. One function is to make sure the transactions is valid. For example, if I want to send 10 Bitcoins to V, the blockchain will only accept if I actually have 10 Bitcoin. If I only have 9, my transactions won't be accepted. And if you have heard of double spending, which is something that have been talking about, and what blockchains trying to solve is double spending. Double spending means that if I try to send the same transactions to two different merchants, hoping that I be able to get them to deliver the product to me, but later on, one of these transactions will be dropped because I actually do not have enough to pay for 2 transactions, but only be able to pay for 1 transaction. And I be able to get by with this because the sharing of information is not fast enough, and both thought they have enough money, but actually I don't. So this is the double spending issue that people are talking about. But here, with the blockchain, basically, just now as I mentioned, the forking things also, you won't be able to spend more than whatever you have because the network, based on all the informations, all the record that they have, they will check against whether you have enough to pay for whatever transactions that you want to do. And there are 2 major consensus protocol is used. One is proof of work, which is used by Ethereum, Bitcoin, and such, where I have mentioned just now earlier on, where they are guessing about the answer for the puzzle. It's totally by guessing. It's just like earlier on the example I gave it to you, 2 plus 2 equals to 4, the same concept. Basically, they are guessing for whatever in front. And this one is a bit different than the cryptography. So yes, the difficulty of the guessing will be adjustable so that like the time forming the block is not far away from 10 minutes for each block. So the difficulty of guessing the answer will be adjusted so they are easier to guess if the time needed is shorter. And proof of stake, basically they do not use this guessing game concept. What they use is like a lottery concept. Think of this, someone have a higher stake in that network, they would have higher chance to create a block. So why people want to stake more cryptocurrency is because they have higher chance to earn the transactions fee. And you might have heard a lot of the time people say that, oh, I'm staking this much of a cryptocurrency with this blockchain so that I can get some returns with the cryptocurrency. And this is mainly one of the reasons of it, because by staking in the network, it helps to keep the network safe. Because when you have some stake into a business, for example, you would want the business to do well. And when you have stake in this blockchain, you want these blockchains to be secure and not to be hacked. So this is the way they keep this blockchain safe in the proof of stake concept. You can think of it like this. If I have put in 10 coins, I get 1 ticket to the lottery. If I put in 20, I have 2 tickets. The more I put in, the more ticket I have. Then all this ticket is going to put into a box. We're going to have a lucky draw. Even though I have more tickets, doesn't mean that I'm going to be the person to be picked, but I have higher chance. So they say proof of stake is more environmental friendly and is less impact to the environment. And people are moving towards proof of stake because of, like, earlier on we mentioned that people are talking, oh, the environment issue, you are harming the environment and such. But both of these consensus protocol does have its benefits as well. Alright, if you have heard of other consensus protocol, they usually won't fall far away from these 2. They are just the deliberations from these 2, especially from the proof of stake.